Hi everyone, welcome to this lecture. So in this lecture, we will discuss the loss function for the logistic regression. Now, in order to create the loss function, the first step is to calculate the error. So error is the difference between the target value and the predicted value. After calculating the error, we square the error and then take the mean. So this kind of loss function is known as mean square error. So we will try to create the mean square error because it is a convex loss function. And we know that if our function is convex, then it is easy to get the global minimum value. But if we see here, this is the predicted value for the logistic regression. So in this prediction, we have seen an exponent equation. So this exponent function is nonlinear. So what will happen when I put this predicted value here? I will not get a convex function, but I will get a bit complex function. Now, if I put this y predict here and solve for LW, I need a complex mathematics in order to simplify the loss function for the logistic regression. So basically, we create loss function so that we can reduce the error and we can optimize the weights and bias of the model. So if I put this y predict here and simplify, I will get this equation. So this is the equation of a loss function for the logistic regression, and we can see that it is for n number of samples. Here there is a negative sign. Here there are a number of samples which are n. So we will take summation from 0 to n minus 1. This yi is the target value of the ith sample. This is the predicted value, and here there is a log. Then there is a second term. Here there is 1 minus yi. This is again the target value, and this is the predicted value. So we can see that we have a log, we have the target value, we have the predicted value, and we have to add all of them. So this is the loss function for the logistic regression. Now it seems that this loss function has so many terms, but the thing is it will not work simultaneously, or both terms of the loss function will not work simultaneously for all kind of labels. Suppose we have a binary classification problem and our label is 1. So when y is equals to 1, we can simplify this loss function very easily. That is, put y is equals to 1 here and put y is equals to 1 here. So what will happen? If I put y equals to 1 here and y equals to 1 here, so this term will wipe out, or this term will become 0, because 1 minus 1 is equals to 0, and I am left with only term. Here I have removed these number of sample term so that I can get the understanding. So I have a negative sign and I have a log y pred I. It means this equation will be reduced to this simplified form if y is equals to 1. That is, we are not using this whole loss function equation for all the labels. For y is equals to 1, we will use only the first component of the loss function, and we have proved that if y is equals to 1, the second term will be 0, and we will get minus log y pred of I. So this short equation, or this reduced equation, will be used to calculate the loss function if our label is 1. On the other hand, if our label is 0, we can also get the simplified form of this loss function. When y is equals to 0, so we can put y is equals to 0 here and y is equals to 0 here. So this 0 will make everything 0 here, and then we get this negative sign, and we get this log 1 minus y pred I. So 1 minus 0 is 1, and then we get this term. It means when y is equals to 0, we again getting the simplified form of the loss function. Basically, now we are getting the second component of the loss function. Now, what will happen? If we want to reduce this loss function, then we have to differentiate it with respect to parameters. So the parameter of the model are the weights. Suppose if we have weights, m number of weights, that is 0, 1, 2, 3, and we have m number of components, it means I have to take the partial derivative of this loss function equation with respect to weights. And then I will calculate this ratio, which is known as gradient. So in the gradient descent lecture of linear regression, we know that this term is known as the gradient. So after calculating the gradient, we will multiply the gradient with the learning rate, and then we will subtract this term from the old value of the weight in order to get the new value of the weight. So in this way, when we put labels y is equals to 1 or y equals to 0, we will get the simplified form of the loss function, where we can perform the gradient descent. We can easily take the gradient of the loss function, and then we can perform the weight adjustment. So in this lecture, we learn how to create the loss function for the logistic regression. We have also learned that the whole loss function of the logistic regression will not be used for all the labels. For y is equals to 1 and for y equals to 0, we will have the simplified form of the loss functions. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.